Thanks for joining. Today is our project work, assignment work. Today we are in day number 20 in our CCNA routing and switching. And here you can see the topology. This is a big topology where our goal is that make sure these devices are getting IP address from the DHCP server, and they should get IP address in different pool range. So here you can see that the list of tasks that we want to do, the list of tasks that we want to perform here is starting from task number 1, configure the switch 110. What are the technology used here? So these switch 110, if you see the topology, I will show you the topology, where we have to go to E00, E01, and we have to make this as an access. And then we have to do the DHCP snooping configuration. We have to enable the DHCP snooping over the VLAN 2000 and 2001, and we have to trust the interface port channel 1 and 2. We have to do the Ethernet configuration as well, remove existing port channel 1. So what exactly you have to do here in this task 1, that make this as an access port for VLAN 2000 and 2001. Then make sure that these ether channels are working properly. This will be port channel 1, this will be port channel 2, 1 and 2, and they are using LACP method. And then you have to go and enable the DHCP snooping over these links, because these are the trusted link. Why? Because they are going towards the DHCP server which is in the data center. So make sure that port channel 1 and port channel 2, they must trust. They are the trusted interfaces. So those things we have to complete in task number 1. Now related to these tasks, if you have any query, please feel free to ask.
No, the tasks are in the share, right? To confirm.
Yeah, configuration I'll share. I will upload that configuration as well. So this is task 1. Likewise, if you go to task number 2, again, oh, this is not completed yet, task 1. So here you have the task little bit more. Enable rapid VVST, set port fast to the default interfaces of all the access switch, port channel 1 configuration, shut down port channel 1 and no shut it. Like that. Up to here you have to complete. Yes, I will share that today. In the same link, I will upload the solution as well.
Okay.
Okay, so what we have to do, we have to configure, it is mentioned that configure switch number 110. Make sure that you have VLAN 2000, 2001 configured. So it is there. Now, oops, go to config, interface E0/0, switch port mode access, switch port access VLAN 2000. Then E0/1, switch port mode access, switch port access VLAN 2001. We have to configure it as a access port. Then it is telling that go and configure the DHCP snooping. So IP DHCP snooping and IP DHCP snooping for VLAN 2000 and 2001. Right. So these two configuration they are telling to configure. After that, we have to make sure that the port channels that we have. So ether channel summary, if you see here, you'll see the port channel 1 is down, D stands for down. Port channel 2 is okay, that is up, but this is in suspended mode. Right? S, small s, if you see the coding here, you will find that the small S4 suspended. That means we have issue with both the port channel. First of all port channel 1 should be protocol should be LACP, link aggregation control protocol. So if you go and check the configuration to the interface 1/0, you will see that it is mode on. But what we have to do, it has to be mode active. So what we can do here, we can go to interface, or how we are doing this. We are doing say interface range E1/0 and 1, right? And then channel group 1. You can do like this. No channel group 1 mode on. You can remove this with no command. And then channel group 1 mode active, right? So this way you are doing the right configuration. And then you should do interface port channel 1 shut and no shut. It is mentioned in the task. So if you do that, after that, if you go and check to show ether channel summary, now it is in the waiting state, means it is trying to do the negotiation. Now it is in suspended state. Now it is in suspended state. That means the other side, I have to go to other side and make sure that other side configuration. So other side is switch number 101. So here if you go and see, show ether channel summary, port channel 1, you can see it is not configured with any of the interfaces. So we have to make sure that this side of configuration is correct, and we have to check that what is the interfaces, what are the interfaces we have. So then you can refer the topology. Let's go and see the topology. Let's go back. What interfaces? This side E1/3 and E1/2 and 1/3. So I can come here to this switch and I'll configure say conf interface range E1/2 and 3 channel group 1 mode active. Now if you go back here, now you can see this is up, SU statically up. So this is up, but still you can see that port channel 2 is down because this is connected. So how this diagram is? The diagram is like this, that you have switch number 110, then 101, 102, and then you have the interfaces. You're bundling, right? This is your switch number 110. This is your switch number 101. And this is your switch number 102, right? Now this link here from this side it is E21 and 23. This side this is E1/0 to 1. This side this is again E1/2 to 3. And below also you have interface E2 to 3 only. So if you go and see, check that. First of all, you can see that this is 1213. Now if you go here and check, so ether channel summary, you will see the port channel to E12 and 13. So I should go to interface range E1/2 and 3 and make sure the This is the configuration. Now if we come back here, I can see that oops, now your port channels are up. So you can see that your port channel is up and running in switch 110. What about 101? Let's see. 101 up, right? Up and running. And what about 102? So 102, 102 is also, you can see up. So one task we have completed successfully, that we have make all the port channels up and running. Even in switch 101, we have configured the access VLAN, we have configured the DHCP snooping. So if you want to see that what type of configuration you have done, if you do so history, you'll come to know that this we have done, the port channels we have done, and we have checked this summary and all those. So basic configuration we have done. Let's go back to the task and see what are the other things we want to do. So here you can see that we have done this configuration, snooping we have enabled, we haven't trusted this. So this task is pending. Go to the interfaces, port channel 1 and 2, trust them. We have done the ether channel configuration. We have removed the port channel configuration, existing configuration. We have corrected the port channel 2. We haven't done the STP. So STP is remaining. Trust configuration is remaining. And set port fast default to all the access. So these three items are still remaining. So what it is telling that go to this interface range port channel 1 and 2 and make this trust IP DHCP snooping trust. So this is remaining. So we have completed this task. Then a spanning tree mode, a rapid PBST. If you are configuring this rapid PBST to one switch, make sure this is configured to all the switches. Any mode you can go and put it, no problem. So rapid PBST is configured. This is task number 2. Then finally, what we want to do, that the interfaces, the interfaces we have, all the interfaces we have, which is connected with the switch, which is connected with the PC's laptop, right? All the interfaces that is going towards the end devices, those interfaces we want to make as a port fast. So we have option. We have option that we can go to the interface by interface and we can make it port fast. How we can make this post fast spanning tree port fast edge, because these are the edge enter, like that we can do, or we can do a spanning tree port fast default. If you are doing default in global configuration mode, that means, what does it means? So it means that all the interfaces, irrespective of interface 1, 2, 3, 4, all the interfaces you are making the port fast. That is the ask in the task, that you should go and run this command. So if you do up to this, that means that we have completed task 1, right? So task 1 we have completed. Let's move to task number 2. Let's see what is there in that. So task 2 is little bit more about the PBST configuration. It is telling that make sure that ether channel configuration is there for switch 101. Actually, we have completed in task 1. Make this mode active. Then you have to enable a rapid PBST. This also we have enabled, but for VLAN 2000 and 2001, This switch should be the primary. This switch should be the primary. Port channel configuration you have to do. Make sure that enable root guard on port channel 1. You have to protect. So this is the root bridge. You have to make switch 101 as a root bridge, right, for VLAN 2000 and 2001. And then you have to protect port channel 1. You have to enable the root guard. Okay. And then you have to configure some HSRP. You have to configure HSRP here. Configure HSRP for VLAN 2000 and 2001. Set the priority and prompt options. Oh, so this task is thus limited to switch 101, that you have to make this, you have to do configuration related to PVST, and you have to do the configuration related to HSRP. For HSRP and for HSRP VLAN 2000 2001, this should be the root or the active. For spanning tree PVST, it should be the root bridge. Like that, we have the task. So let's go and pull that server. Here we have this task. We have to configure switch 101. What you have to do, most of the things we have done, but we have to go and set the spanning tree. 101 should be the root bridge. So what we can do, spanning tree priority or a spanning tree VLAN for 2000 and 2001. The that command is spanning tree VLAN. I'm right. 2000 to 2001. Okay, like this. Oh, you have to give the range. Otherwise, okay, one by one you can go. If you want to give the range, likewise also you can do. Say priority 0, lower is the better, and then you can go to 1, or you can go and give the range like 2000 2001, like that. Any command will fine. Like here you have to go one by one. Here in the single command you can set the priority. So this is one of the tasks we have. Anyways, we are running a spanning tree rapid PVST, then we have to set the priority. Next task, what we have to configure the HSRP. So before doing configuration for this, let's go and check the interface VLAN 2000 and 2001. So 2000 and 2001, you can see that we have the IP address configured. Now we have to go to VLAN 2000 and configure the HSRP, right? So let's do that. What is that command? Standby, the group name, and the group name we can go and use the VLAN number as well. So I can go and use the VLAN number and the virtual IP, VIP IP. If you are in the VLAN 2000, so you can use the VIP IP as a 2000 10 1 101. Standby number, I can go and use anything. This number should be in between 0 to 255. Let's take 100 and IP 10.1.100.1. It is telling the set the priority. By default, it is 100 because since this is the primary, so we'll go and set the priority as 110. Standby 100, or well, version command. What other things we can set? We can go and set the preempt priority. If we have timers, you can go and set. You can go and set the version is to right. So this is the basic minimum configuration we can go and do. But if you have certain more ask, you can go and add more task as well. Later on, we'll come back to this, and we'll enable such type of features such as the helper address and other features. So, what is the configuration we have done? This standby 0 print. What is this? Standby 100. Priority is okay. I do not have 0. Let's see. So you can see that we have version, we have this, we have this. So we are good actually. Now the same thing we have to do with VLAN 2001, and instead of 100, we group is 101, 10.1.101.1, and standby 101 priority is 110. Then standby 101 permission is enable, and then you can go and verify the configuration. So 1, 2, 3, 4 lines. This is the task we have. Let's go and see the task. Ether channel configuration. Okay. This we have done. Spanning tree is there. We have enabled it. That this we have done. Port channel we have done. Root we haven't enabled. So we should go to the interface one. We should enable this. This is pending. VLAN interface configuration for HSRP. This done. Configure HSRP for VLAN 2000 and 2001. Set these options. So only one task is remaining to configure the root guard that we will do. Then I'll come to task number 3. We're telling it go to interface port channel 1 and a spanning tree guard root. This is the port channel 1 that is going towards the switch 110. We want to protect this interface. So that's why in this interface we have enabled the guard root, right? All right. Now let's see the task number 2. So what we have done, we have completed task 2. Oops, who is joining the call? You guys are there with me?
Yes.
All right. Solution is there. I'll upload the solution in that. But you can understand what are the things we are doing. So now let's move on to task number 3. Same thing you have to do. Enable PBST, but here we have to give the higher priority. Higher means this is less preferred. So 0 means better, and 4096 means second option. So this is the root bridge. This is the secondary root bridge. Like that you can think. So we have to set that. Then enable the port channel 2. This interface, secure this. Actually, port channel 2 is already up and running. We have to secure this as a guard root. Then we have to do HSRP configuration. And then finally, we have to set the DHCP relay for both switch 101 and 102. So these configuration we have to do. Let's go and let me pull the server here, the lab. Okay, here we are. First of all, I have to go and enable the DHCP services. Interface VLAN 2000, IP DHCP helper, IP DHCP or IP helper address, like that, helper address. 10.2.255.211 is the DHCP server address. And even we can go and trust the relay information as well. So these configurations we can do both the switches. I can go to interface VLAN 2000 and IPDSCP, what is that? IPDSCP relay information trust. This configuration you can do actually in all the interfaces. Now let's move to VLAN 2000 and do the HSRP configuration, but let's go step by step. The step number one, the spanning tree VLAN 2000 and 2001 should be priority 4096. Now, if you make this priority, if you do this configuration, that means that switch 101 is the root. So if you see this 2000, it will tell that this bridge is the root. And if you check 2001, this bridge is the root. Because we have set the priority as a 0. Now if you go and check here, do spanning tree for VLAN 2000. This is the secondary actually, priority is 2000. It will not tell that I am the root because this is the backup link or the backup root bridge, like that you can think, because we have set the priority as a 2000, 4096, my bad. The priority is 4096. We have set that 4096. We have set that priority as a 4096 to both the VLANs. Likewise, we can go to port channel 2 and we can do this spanning tree guard root. So this type of configuration done. Now we can go to interface VLAN 2000 and we can do the standby configuration, right? So standby version 2, oops, 2, not 1. Then a standby 100 IP, VIP IP 10.100.1. This is the VIP IP, virtual IP. Then the priority is, by default, it is 100. If you do not give, nothing will happen, because anyways we want switch 101 as a active and this should be a standby. Likewise, we can go to interface this and then we can go and set the version as a 2, and then the preemption we can enable, and then we should go and give the VIP IP. VIP IP is this. We can check, do show or run interface VLAN 2000, 2001. This is the configuration. Now, if you want to verify this configuration is working 100% or not, you can go and check show HSRP or show standby brief. So this will tell you that what is the priority. First of all, what is the group for this particular VLAN 2000? The group ID is 100. The priority is 110. The state is active. Local is active. A standby is this. This IP is switch number 102. This is the VIP IP. Other side is again negotiating. Now you can see this is full-fledged, negotiated, up and running. So I am the active one and this is the standby. Likewise, if you go here and check, it will tell that this switch is a standby. Why? Because its priority is less. And this is a standby. Active is who? Active is this switch. This is switch 101. Standby is local. These are the VIP IP. Right. So I think that we have completed task 3 as well. Let's quickly see that. Check that. Yep. We are done with that. Now task 4 is very small. Simply you have to go and enable the OSPF. I haven't added the complexity related to OSPF because of this is our CCNA classes only. But task number 4 and task number 5 is very much related to OSPF. Now here I have added some of the difficulty level, creating virtual link. But this is also not part of CCNA, but I have added that. I'll explain you what exactly this is. So let's try to complete task 4, 5, and 6 together, because task 6 is just one line. Again, I haven't added the complexity related to OSPF. Is still OSPF. We are learning as a CCNA level. Let's understand the questions. Enable OSPF on Ethernet and loopback interfaces of these devices. Uh, in my lab, I haven't enabled router 21, but likewise, we can go and enable it. In your lab, you can go and enable router 21. It is actually not required in this particular task. But yeah, you can go to this router 21, you can work on it. In the solution, I think I have added this configuration, but I'll go and enable OSPF in between 11 and 12. Then configure switch 101 and 10 switch for area 1. So what is happening in OSPF? If you see OSPF, OSPF is area based routing protocol, where your backbone area is area 0, and then you can go and connect with any non-backbone areas like area 10 and 20, etc. So suppose this is area 0, this is area 10, this is area 20. Now assume that there is one case that somehow you can't go and directly connect area 0 with any other area, but the other area is connected with area 10. Maybe some company merger, maybe some small company which is connected with some other area. Suppose here I have some area 30, for example, or 70. Now this is not directly connected to area 0. That means that OSPF LSAs will not process. So in those cases, what we are doing, we are creating some sort of virtual link in between area 0 and area 70. So the area 0 is thinking that I am directly connected with area 70. We are creating some sort of tunnel in between the areas. That's the concept of virtual link that we have to create within the switch 101 and 102. And finally, we have to disable the passive interface configuration in switch 101 and 102. Make sure that OSPF is working fine.
But Rakesh, you say virtual link is la tunnel or what is that?
A virtual link is tunnel to pass the non-directly connected areas within the OSPF.
But we need to do any configuration for that or only in the OSPF?
Yeah, we have to do
Oh, really?
configuration in OSPF. I will show you that
Okay.
configuration. Okay, so let me pull my server since it is gone. There it is. We'll see that one by one. I'll check that. So now we have to configure this router's interface range, loopback 0, and all the interfaces. What interfaces we have in this routers? So we have interfaces E0/1. You can refer the diagram. And we have to enable IP OSPF, OSPF1, area 0. Likewise, we can go to the this and IP OSPF1 area 0. Now, once you do this configuration, then you will see the OSPF neighbors. Now we'll see that we have OSPF neighbor. This is switch number 102, 101, router 11. So all these switches means we should see these three neighbors. Let's make confirm this that we have these three neighbors. Okay, so we have these neighbors. We have enabled this. Likewise, you can go and enable in router number 21 as well. no problem on that. And if you can go and check do show IP OSPF routes or do show IP route OSPF, you are getting the data center routes as well. That's good. 10.2 is nothing but data center. But before proceeding further, we should go to switch number 101 and 102, and we should create the virtual link. Virtual link, uh, because it is mentioned in the question that we should go and create the virtual link. Let's see the question here. First of all, this task is done. Enable OSPF Ethernet loopback. Enable OSPF on Ethernet and loopback interfaces of switch 101 and 102 as well. So we have to enable that in. We have to do OSPF configuration to switch 101, 102 as well for area 1. Okay. Configure OSPF router setting. Also create virtual link in between switch 101 and 102. So we have to create virtual link in between switch 101 and switch 102. So let's see that. First of all, let's see the OSPF default configuration we have here in switch number 101. It is there. And if you go and check any of the interface, show run interface E that is connected with the routers. These are the connection that is going. So this is the connection that is going towards the router. So it is in area 0. And this is the connection that is going to the other side. 0 to other side means if you see the diagram, you will find that the switch 0 0 0 1 0 2 0 0. Okay, these two interfaces. 0 0 and 0, actually 0 0 and 0 1. Yeah, that's right, 0 0 and 0 1. I should remove this interface. 0 2 is here. So you have 0 0 0 1 and 0 2. 0 2 is your replication link that is going to other data center. This is point to point OSPF point to point configuration here, going to other location, and 0 0 and 0 1 is going towards the router. 0 0 and 0 1. So that's fine. I can go here and I can verify. So you can see this is the backup link configuration 0 2. If you see this 0 2 configuration, this is the backup link going towards the data center. That's good. So backup link configuration is there. That means that this router to show IP, this switch OSPF neighbor, it should have neighborship with the data center as well. So 201 is the data center switch. And then it has the neighbor relationship with the other routers. 202 is the data center switch. This is the data center IP. So my OSPF configuration, I am just checking my OSPF configuration in these switches. They are perfect. But we have to create virtual link in between switch 101 and 102 as well, which is easy only. We can go to router OSPF1, create the virtual link within the area. What is the area? Within the area 1. And you have to give the router ID or the switch OSPF router ID like that. So what is that ID? If you go and see this like this, show IP OSPF database, you'll get the ID. This is the ID, router ID. And if you want to create some sort of summary, 10.1.0, if we can create it, but it is not required. Without this also it will work. Summary of my OSPF addresses or my private addresses. Likewise, I can go to this switch and I can go to router OSPF1. I can create virtual link, but this time this is just the reverse. And then area 1 range, say 10.1.0.0 to 255.0.0 IP OSPF neighbor. Now if you see the neighbor,
Okay, can review again how you set up the virtual link? They
yeah,
are in different areas. That's why.
in between switch 101 and 102. So in switch 102, you should give the router ID of switch 101, and in switch 101, you should give the router ID of switch 102. So like that, they will go and create the virtual link, right? Sure, run interface. Let me check that what is the configuration over the E0/0, which is connected with router. So, sure, run IP OSPF neighbor. Do show IP OSPF neighbors. Now, so what you can do here, make sure, so if you read the question, that's why this is not very much like CCNA thing we are doing. If you see the task here, the task will tell you that configure switches 101 and 102 for OSPF area 1. So enable these interfaces for OSPF area 1. So what I am telling here is this, that go to range loopback 0 and E0/021 and make this IP OSPF1 area 1. Wow. I'll tell you why we are doing this. Oops, IP OSPF1 area. Yeah, that's right. So IP OSPF neighbor. I have almost destroyed everything. Now we have invalid packet mismatches and all. So now you can see that we have some error, and because of this configuration we have the error. So let me recover this error. I can go here and make this area 0. I can go here and make this area 0. So the interfaces that we have, see the interfaces we have in the switch, they are part of area 0. But we are creating virtual link in between these devices in switch 101 and 102 as area 1. So that's the change that we are doing here. And virtual link, I already told you that why we are creating, that if you are assuming that your interfaces that you are connecting. So what I am telling here is this: if you see do show run interface E0/2, that is the link that you are connecting from your HQ to data center. Now, if you go here to switch 10 to 201 data center, oops, switch 201. So if you go here and see, so run interface E, what is the interface there? I think that is 00. Yeah. So here you will see that this area is also in area. So if you are assuming that everything is in area 0, so no need to create any type of virtual link, anything. But if few of the interfaces are in different area, so you can go and create the tunnel. This is just for the task purpose that we are creating here, just to add little bit complexity in the scenarios. But if it is not required, in this case, if you just wanted to get the IP address from the DHCP server, it is not required actually. You can work as it is. There is no problem at all. Right? You can create it, not create it, doesn't matter. But why we are creating? If your backbone area is connected, so area 0 is connected with area 10 and area 10 is connected with area 20. So we are creating virtual link in between the area 20 and area 0 just to bypass the area 10. That's the concept of virtual link.
But needs to be some reachability between
100%.
area
Yeah.
0 and area 20.
100%. Reachability always, always, yeah, always.
Okay.
You should have reachability. You should have the point-to-point IP configuration, etc. So at the moment your LSA will pass, you have the reachability. Think about GRE tunnel or
Mhm,
IPsec tunnel. If we do not have tunnel reachability with the physical interfaces, they will never work.
mhm.
So
Okay.
100% we have the reachability, otherwise it will not work. Okay. All right. So we have done those configurations. Now it is telling that, oh, disable passive interface over Ethernet E1/2. Let's quickly see that the interface that we have here, what's the interface? Oh, E1/2. So in these switches, let's go and check the configuration related to E1/2, and then we'll understand why we have this virtual link seems. So here we are. Pull my server. Come, not coming. Okay. So what I'm telling, if you go here, what interface is this? E1/2, right? This is the E1/2. If you go and check the configuration, do show run, a show run section, OSPF. Oh, wow. So 201, they are not having passive interface. What about 202? Show run, let me change the host name. And show run section OSPF, show run interface E 1/2. 2/1 is not an interface. Okay, 1/2. And what about show IP OSPF neighbors? So I am neighboring with 102. That's fine. And this switch and this switch and this. Oh, so everything is good. And show run show IP OSPF neighbor. So there is no passive interface. My OSPFs are running fine. Everything is okay. Uh, Maybe in your lab when you check this OSPF, you will see one configuration here, like interface E1/2, IP OSPF 1, or maybe passive interface. Some configuration you will see related to OSPF passive interface, etc. that you have to go and remove it. But I'm not seeing anything in my lab. In your lab, maybe the interface is running in passive mode. That means they will not form the OSPF relationship. What is that? Passive interface? Let me check. IP OSPF1 or IP. What is that? Passive interface configuration? Router. Let's see. Router OSPF1 passive interface, like that you have, like uh, Ethernet 1/. In your lab, maybe you have this command, passive interface E1/2, that you need to remove. If you remove that, then you can see the neighbor relationship will form. We want this. So at this point of time, actually, we are very much good with these tasks. To remove the complexity, we can go and remove this virtual link part. Otherwise, rest everything is okay. Now the final thing we have to do is to enable the DHCP configuration and make sure that host 11 will get this IP and host 12 will get this IP 10.100.100 10.100.1.100. That is the last thing we want to do. So let's go to the DHCP server. This is our DHCP server. What you can do, you can exclude some addresses, 10.1.100.1 to 10.1.100.100, because you want the address should be released from 101, right? Then you can go and create the pool, say for host 11. Network you can give 10.1.100.0/24, and default router is the VIP IP. Then you can go give the lease time and all those things, like 24 hours and all. Then we can go and create the other host as well. For example, host number 12. There also I can go and define the network as 101. And then we can go and give the default router as this. And then we can go and give the lease time like this. And check the DHCP configuration. Right. So this is the configuration we have. Right. So we have done actually, I think, everything so far. So the devices should get IP and they should work, seems. Right. Let's see. Should run. Finally verify that to show run interface VLAN 2000. So they have all those necessary configurations. Let's go to host 11. To app interface. Leave. So they should get some IP from DHCP. If everything is okay, everything is working fine, DHCP server should go and release the IP. It also has the neighbors and all 201, 202. And if you come here and if you ping 225521, this is your DHCP server. From my switches, I am able to ping. From my switches, I am able to ping. to show run. OSPF is also there. Okay, so seems everything is okay, and the host, they should get the IP E0/0 shut and no shut. Okay, so there are maybe some lines, some steps are missing that we can check. I will share you the IP DHCP. I will share you the full configuration, and you can work on that tomorrow. Again, I will do this lab, but tomorrow you will understand this more. I'll not explain all the steps that we have covered so far, but we'll go and check only the um, output. I'll show you that it should go and get the IP. I need to shut down, no shut. I need to default this configuration. Actually, some old configurations are there which is conflicting, and I can see that my virtual link is not coming. So I will go and reload this lab. This virtual link, I should see 101 more neighbor here, that is 102, that the virtual link. Somehow, because I have made everything in area number 0, in our lab everything is in area number 0, that's why this is not working. I have to make the link in between the switch 101 and 201. Actually, switch 101 and 102 as area 1, right? Why it is that we will discuss in the next session, and then it will get the IP address here. You will see some IP address released from the DHCP server, right? That I will show you. But the configuration is 100% correct. See, it is trying to release the address, but it is in selecting a state. No one is receiving the IP, but it is trying to release the IP, but no one is getting the IP due to some configuration conflict related to OSPF. Show IP, show IP in brief. That I'll correct this, the virtual link part. I'll default the configuration and correct it. Meanwhile, so far, if you have any doubt, please feel free to ask and try to go through this. I will go and add the solution here just after this slide. I'll add the solution just after this slide, next slide. Okay, please go through it, and uh, tomorrow just we'll spend just 10 minutes in this, and then we'll continue with the Python setting.
Okay.
Thanks for joining. Today, we are going to continue our project work, CCNA project work, related to the configuration that we were doing yesterday in day number 20. Our target is this, that these hosts must get the IP address from the DHCP server that is there in the data center. So we are going to do all the configuration. Configuration actually we have done today. What I will do that I have this solution here in the notepad. Simply I'll go and post, and I'll show you the result. And after that we'll move to Python, because for Python also we have to work on one of the projects. So we will see that. First we'll complete CCNA part, and then we'll go and work on the Python part. So let's do that. Let me go and so here you can see that we'll start with switch 110. Simply I'll go and copy paste the configuration. You can say I have created this solution. I will send this solution over email as well. This solution is there uploaded in the notes, CCNA notes as well. All those configurations, switchport mode access and PBST and all those configuration we have here. First target is this, that make sure that your ether channel is up or not. It should be up and running. And all the devices in HQ, they are in area 1. So that's why we will go and create the virtual link. Even the SVIs also, they are in area 1, OSPF area 1. Now we'll move to switch 101. The configuration. Then we'll go to switch 102. Same configuration that we have done yesterday. And this is 102. Then router number 11 and 12, they are part of, these interfaces are part of area 1, OSPF process 1, area 1. So we'll go to router number 11 and router number 12. 21 also, if you want, you can configure it. Then you have to do the configuration here to the DHCP server. You can see simple pool configuration and excluding these addresses and creating the pool with these networks. So I can go here to switch 211, doing the configuration related to DHCP. And then finally, these switches, I'm enabling the OSPF and the virtual link that we are doing yesterday. So let's go and do that. Switch 101 and 102. 101 and then 102. Now this is the full configuration. Now what we will do, we'll go and verify the links are there working or not, the ether channel is there working or not, etc. So if I am here, let's see, to show ether channel summary, they are up. We can see SU up, they are up and running. Likewise, if you go to switch number 101 and let's say to show IP OSPF neighbor, so they have neighbors. You can see so many neighbors are there. This is the virtual link, OSPF virtual link interface. Switch 101 and 102. Then it has neighboring with the data center switch as well. Then these two routers, and then these VLANs as well. So what we can do, that we can go to router OSPF1. We can make passive interface VLAN 2000 and 2001 because it is not required in our case. So passive interface VLAN 2000, 2001. And now we'll see that the OSPF will get converged. You can see that we have 4 neighbors. Now if we go to the host 11, now you can see host 11 is getting this IP from DHCP server. Brief interface E0/0 or E00. So it is getting IP from DHCP. If we go to the DHCP server, do show IP DHCP binding. You can see that it is releasing this IP and this IP active. We go to host 12. You can see it is getting IP range of 101. 11 is getting IP of the range 100, starting from 101, because up to 100 we are excluding in our database. Right, so this is the configuration related to our CCNA project. Even I will email you as well this entire configuration. It's a working one. All right.
Okay,
Great.
so you're gonna send an email for
Email
the
as well.
configuration, or
Yeah.
okay, email as well. Because I was checking
Uh,
on the drive, I didn't see it.
I haven't
For
uploaded that configuration.
okay, okay.
I will upload. Let me do one thing. Let me put this here in the chat window, and you can download from chat window as well.
Yeah, that would work.
Yeah. CCNA. Where is the project? What's the name? Project solution and project task. Yeah, I just uploaded here in the chat window. You can take it from chat window. Okay.
Thanks. Yeah.
All right, great. So now what is the next target we have? Next target we have is the Python related project. We want to log into the devices and we want to do configuration. You can see that different files are here. So let's start with small, and then file number, this is our project, 5_menu.py. Slowly we'll understand these scripts. These are nothing but logging to the devices and doing some basic configuration. How you're logging to the devices and doing the configuration, for that we are going to use one Python package, netmiko, and importing the function connection handler. Connection handle means handle the connection related to SSH and doing and pushing some configuration, etc. So this connection handler, you can see that it is used here to do the connection. You can see once you have the connection to the router, then you can go and do enable, means enter the enable mode, and then you can send the configuration. Then you can send the configuration related to access list, interface command, and then finally connection, saving the config, connection disconnect. So you're opening the router here, actually logging to the router here like with connection, and then it running the commands like CLI. You're running the command here. You have the command set somewhere as a list. So here you can see that we have list of command, access list of commands. For example, access list command, these are the ACLs I want to create. These are the configuration I want to configure over the interface gig 01, like this ACL will go and apply to interface 01. So these are the list of commands. You can see this is the list. Easy and straightforward. What is there in list? Items. So I have item 1, item 2 in this access list command. Then item 1, item 2 in this interface command. And when you have to send this command to router, what you will do? You will use this connection send config set and then the interface command. Send config send set, then interface command, and then you are saving the config and then you are disconnecting it. So these are the functions here actually that is used there to doing some configuration to the devices. So first you are logging to the device. It's easy and straightforward. We have here, you can see the router related attributes. This is what? This is the dictionary, right? Router dictionary. What are the things you have? Key and value. Key and value. You have key and value, right? Key and value. Key and value. So this is the router. With this router, what we are doing actually, you can see that we are using connection. We are restoring the connection with the connection handler package that we have, or function that we have, router. So we are logging to the router. You can see star asterisk means like everything, all the arguments. So it is taking all the values here to the router. This is one of the program, package program from Python, just to log into the device. So via this line, we are logging, and via these lines, we are pushing the configuration. right? So what is the Python function here? Python is helping us to logging and storing some logging credentials, and then with Python package we are sending the configuration one by one because we are using well-defined package netmiko. Now, apart from that, we know that we have to go and define some packages from our Python knowledge. We know that how to define a dictionary. We know how we can define a list. So here you can see the use of dictionary, use of list, and then how we can go and store something, some output. So from here we are generating something and storing in connection. And then we know that use of functions. So this is nothing but functions. So connections dot functions, this is some functions, this is function, and finally we are disconnecting and then we are printing that job done. So this is, you can see this is the way that we can go and configure devices. Now for this section, what you can do that we have one free tool available, that is Cisco GNS, sorry, not Cisco GNS, GNS3, where you can go and import Cisco routers, switches, and all those. So let me try to run this GNS3, and
Hello.
yeah, Ray, you're telling something?
No, I'm just saying hello, everyone.
Harry, thanks for saying. Who is joined by iPhone?
I think it's Jesus.
Yeah, I think it's just
All right. So what we have done so far that we have completed that CCNA project, and once we completed that,
I have
these,
I have some
these,
questions, Ranesh.
yeah, please ask.
The first one is on Python to use the Nemico. I guess it's a library that
Library,
or
yeah.
is extension, or how we do import that library so we can start using.
Pip install netmiko you can do.
Oh, okay, with the from the terminal.
Yeah.
Mm.
So simply you can go to your
Pim netmiko install
install
netmiko.
netmiko.
Yeah, right.
Netmiko and paramiko, all those parameters you can, and since I already have,
Okay.
then you can do pip install. It will tell you if the libraries package are not there, then it will tell you that okay, you should go and install it. It will throw error. So in my case, you can see that I already have this paramiko and netmiko install, but you can do pip install for paramiko and netmiko.
Yes, it's installing from makes sense. The other question, when we well, I saw your code there to send the commands that we want to send
Yes.
to the switch, or in this case the router. But what
I
in the case we want to only read information? Is there another command for that? Like only use the show running configuration and get the information?
okay, I'll come to that. One second, just a second. Let me save some memory in my laptop. Yeah, anything is there. Anything is possible. Anything we can do. I told you earlier. Read, write, storing somewhere, reading from file, storing something in the file. Each and everything we can do. We are able to do everything. Okay, so here we are going to start the GNS3. DNS3 software also I will upload to the shared drive. Although this is free tool, anyone can use. Anyone can go and use this tool. You can download from their website and use it. What you may not get is these images. Even these images links are also something like freely available. If you do little bit Google, you will get it. Anyways, our purpose is to work on the projects. Maybe I have any running project. Let me see. So in this particular lab, you will see GNS lab. There is one automation tool as well. Automation tool means that they have created a small Linux system that you can connect here. Let me show you that what exactly I am taking. So either you can save your project and call like I am calling. It's very a small type of project you can see. But on the other hand, you must see that my laptop is green, my GNS3 VM is green. So you need this software and you need one VM to run this, right? Okay. Let me try to start this. Yes, it is becoming green. It is becoming green. What I'm telling here is this, that if you go to click here, you will see this icon here. It's very small. It's like Linux and desktop, and Penguin is there in that. This Linux icon. It is there in this GNS3 by default. And this is there by default. It has all the automation packages like Python and everything. And even what you can do, you can connect, like I have connected, you can see one switch. L2 switch is there by default as well. You can simply click and put here. So your switch will come, right? So you can see it's very small connectivity. I have one router, I have one switch, I have one cloud, I have one NAT, right? And even I have created one small video as well, that how to install GNS and how to import these routers and these devices and play around with this. Now, when you are importing this, there is one option called edit configuration. Edit config. Again, it's very small. It's very small. Let me do one thing. So in this edit config, what you can do, that DHCP is there. All these things are like some comment is there, comment type of symbol is there. For DHCP config, just remove these comments from here, auto and this. So it should get IP from DHCP server. And that's why you'll see in this diagram, I have created this NAT and cloud. Let me do one thing. Maybe it is little bit confusing for you. So I will do one thing. Let me stop this project. I'll create one new project for you. We can go create file, new blank project. Maybe you are not able to see Python project. That's the name of my file. Now you can see that is the blank, nothing is there. So I will go and take one automation server, like simply take it and drop here. Now it may take some 30 seconds or 1 minute. Don't worry about that. Then I'll go and take this router. Now it is coming. Then I'll go and take the switch. Now I'll go and take this NAT. And I'll take this cloud as well. Cloud is there for external connectivity. Then you can see this cable to connect it. connect to the switch and router, and then Ethernet, and then this cloud. You can see cloud and connect. So now you can see the connection. Connection is done. Then I simply go and check the config. You can see that this config here, let me copy and paste in the notepad so I can show you that. See, this you have to go and remove. By default, it will be, it is not taking this IP addresses because this is commented. Remove those comments. So I'll go and remove those comments from here. For me also, it's very small. Generally, it is not that much small. I have some, in my laptop, I have some resolution issue. And okay. All right, then we'll go and start this. Now I need to log into this particular device. What is the IP? It is showing that console is port number 5000. So I can log in this device to that port number 5000. Let me try to do that. So I can go and do 127.0.0.1 because it is connected with local host. So I made telnet to port number 5000. Let me see. What happened? Okay, let's wait. Let's go back to the, even if I click here, it will open that putty as well because they have the integration. So if I click here, okay, no problem, I'll click router 1. Let me try to open router 1 first. Network automation is coming. System is little bit slow. And what IP it has? So if you go and do IP address or what is if config? So it has IP 192.168.11.156, right? And what about this particular router? So I'll do one thing. I just wanted to see the interfaces. So I can select and use show hide interface labels. So now they have the interfaces. And I want to open this router as well. Let me try to open that router. Is opening. Show IP interface brief. Fast Ethernet 0/0 is showing shutdown. I'll do one thing. Interface FA 0/0. No shutdown. And IP address DHCP. So it will take some IP from DHCP. It is taking IP 157, 192.168.11.157. That's great. Let's go to the automation server. I think it is, let me reconnect. So you can see that we have the automation server and change it. What I will do first I will go and enable some sort of SSH here. Enabling the SSH configuration. So from my script, I can SSH to this device. Let's go here, change the setting to maybe 14 so you can see it properly. So we'll do one thing. Host name, you already see R1, IP domain name. Suppose this crypto, you know that to create the SSH, you have to give the host name and the domain name, then crypto key, generate RSA modulus, general keys, modulus 1024, for example, even 2048 is also okay. So we should generate the crypto key, and IP SSH, for example, version is 2. Then we should create the username, and username, for example, admin, privilege 15, password. Why I am using this? Because in my script, I'm using username as a admin and password is this. But in my script, the IP is, now this is the IP address to the router, 192.168.11.157. I can go and check this. My router should be reachable from my local system. At the moment, which is not reachable. We'll see that. Let me go quickly and configure some basic things here. If it is not reachable, no problem. We'll do something. Now, what you need to do finally, you have to go to line VTY024 and login local, right? And transport input SSH, transport output SSH. Like that, you have to configure this device to get the SSH access and all. Okay, now what I will do, I will go back to my automation server. Here I have my automation server. Let me try to reconnect this. And let me change the setting. Appearance change. Now from here, I'll try to SSH. What is that IP? This 192.168.11.157. Yes. And password Cisco. Now you can see that my SSH is completed. I am here. So what we will do in our programming, that we will go and do the automation from here to the router, right? So I can go and create one script here. I can use nano 1.py, and then we have the script here. I just explained you how it is working and all those things, connection and all that. Even in case if you have missed, you can watch the recording. I have recorded that. Then we will go back to our automation server, paste it, and name it Control O, Control X, I think. Let's see. So you can see that you have your script, and then we'll run it. Python 3 1.py. So now you can see that errors are coming. What errors are there? First of all, the naming nano 1.py. This host name that we have pasted should not have the comma here. So let me go and save it and try run one more time. So now the script is running. Access list and configuration successful. Now let's go and try to SSH. Even I have that router open in other window as well, but no problem. I'll SSH to that device and do show IP access list You can see the same access list we have configured, and then show run interface FA0/0, and this configuration we have applied. Oh, in my script, I should apply it to FA0/0. Maybe it is not up. This interface is not there in that script. So let me copy this interface, go back to the program. Oh, my interface is gigabit Ethernet. Oops. Go back to the program. Okay, press yes. Come here, and because this is nano editor, so you can edit it easily. What is the name? I just forget the name. Fast Ethernet, maybe 0/0. Let me see. Fast Ethernet 00. Okay, and let's go and run this program one more time. Once this will get completed, I can open multiple window here. See, run interface FA0/0. I can see this, but what? Oh, so while this operation was on, I simply log into the device. So that's why it has some error. But you can see now it is pushed. The configuration got pushed here, right? So you have your server, you have your router. You can see the changes. Likewise, you can see that. What about the SNMP and ACL configuration? The logic is same. I have one router. I have defined this router attributes as a dictionary file. Then you can see the list of configuration items, for example, the ACL, the interface configuration, and then SNMP configuration. And then you are using this obviously this library package, connection handler, putting inside the connection, and these are the configuration steps. Go to the enable mode, send the config for ACL, send the config for interface, send the config for SNMP, save the config, disconnect, and final message, right? So the router name that we have, actually that is the host name that we have is different. And let me remove this time. This is some different IP, and even the interface is fast Ethernet 0/0 seems. So I can do this copy. I can go to my automation server, Python, or will create the file. So nano 2.py, Control O, Control X, enter, Control O, enter, Control X, go outside. Just make sure that 2 is there. And then we'll go and run this. Yeah, you are asking something. So now what it is telling that incorrect IP, this is wrong, firewall blocking. Why it is blocking? Maybe the ACL is there that we have created now, which is blocking the show IP access list, the connection. Now you can see it deny. So you can see that ACL is blocking things. And what is this IP? This IP, if config, this 11.156. Okay, so I'll do one thing. I'll go and create IP access list. This is extended, right? or maybe if you give the number 100, I can't edit. If it is named, it's not named, it's ACL. Okay, no problem. Permit 192.168.11.156 0. Mm. Mm, 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 mm. That's the thing. I should create some name-based SEO so I can play around with that number and sequencing and all those things. Anyways, IP, let me see, show run section access list. What access list we have created? Mm, 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 mm. 192.168.156 and but the thing here is it is coming below this deny statement. That's the problem with the numbered with ACL. And then we'll create ACL like this, and then we'll create ACL entry like this, and then by default you know that deny statement is there. Let's go and see this. This ACL is already applied to the interface. Let me try to run that script one more time, or even we can try to SSH to the router. I can see that something is happening because ACL we have the permit statement. Now everything is configured. Do show run SNMP. You can see that we have this SNMP configured. ACL and other things already we know that is there. So in this you can see that admin, the RO, this got created, right? So you can see that how easily you can go and configure the devices. Now I have added AAA. Same way, access list, then this, then SNMP, then I have added AAA configuration. And then I have added this try and exception as well, that if something will happen executing these commands, then it will go and throw the exception. So those exceptions I have added and then configure the devices. So what I need to do here, simply I have to go and change the router. Oh, in this case, you can see I have added 2 routers. So actually 3, 1, 2, 3, 3 routers. That means that if we have a good number of devices, then in the router, now you can see this very interesting. Now we are creating one list, and within that list we have dictionary. So within that list we have items as a dictionary. So item 1 as a dictionary, item 2 as a dictionary, item 3 as a dictionary. So one by one it will go and check these devices and try to configure all these things like ACS, AAA, SNMP. And since we are dealing with number of devices, so I have put everything within the try and the except block. So if any error will come, it will throw the error. So what we can do here is this, that we can go to our lab. I can go and connect one more device here. I can go and use the FA00 connect, and then start this router as well. And then for this router, also we need some SSH related configuration. So we will go and check. It's loading. Router is loading. What are the SSH configuration? We'll do the SSH configuration here as well. Check the appearance, change the settings, go to apply. Hostname, suppose R2 already there. Then IP domain name cisco.com. Then crypto key generate RSA general modulus 1024 just to generate the key. Then create the username, admin privilege 15, password Cisco, like that you can create. Then you can go to even you can do IPSSH version 2. Then you can go to line VTY 024, login local, transport input SSH, transport output SSH. And you can even see, you can go to interface FA0/0 and no shut and IP address DHCP just to see that, to show IP interface brief FA0/ what IP it is getting via the DHCP server. So it is getting 158, right? So now according to, I can go to my script and I can give the IP 157 and 158. These are the two IPs now we have. 157.1. I will not change it just to show you that how this error block is working. This is unreachable device. I will leave it as it is. And then I have fast Ethernet. That's it. So we have modified the configuration. Then we can go to our automation server. Here we have nano and say 3.py, but yeah, the ACL is wrong. So I should go and correct the ACL as well. Otherwise, what will happen? That it will not reach to the device. So I will go and correct this ACL here, copy this ACL and go back to my ACL. And I will go and paste the ACL here. Like this. And I can give some space here. Anyways, you don't need to do this much. If it is there in that line also, there is no problem with that. And this is our list. Right, this is the modified ACL we have. Because we want to permit the automation server as well. Now let's go back here. 3.py. Control O, enter, Control X. Make sure that you have 3.py there. Then python.exe. Python 3. You don't need to do exe. Run this. Now you'll see that one by one, it will try to log into the devices. You can see we're getting the message. There also it should go and log in, try to log in. The moment it is in the first router, we are getting some syslog messages. Now you can see router number 2. And you see the script as well. So 157 configured successful because we have that print statement. 158 is successful, but the third router is not reachable. So it is telling, is throwing error. Right. So now we can go to these devices. We can go and see the section ACL or access list, SNMP, AAA, all these configurations you can see. So AAA we have configured, the access list we configured, SNMP we configured, right? So this is the way that you can go and configure your devices. I have added all those. Slowly what I have done that I have added little bit more complexity in the next script. So in this script, you have multiple routers here. You can see on the top as well. You can see on the top as well. I have added some error handling scripts, like, packages as well. Some SSH exception will happen, then what will happen, like that. The configuration and list is almost same. Now in the try and the except block, I have added some more error handling configurations just to make sure that our script is little bit more standard. So I can go here, and if I go and add these lines here, now these scripts I have not added in the shared drive. I don't want to mix it. So better I'll go and change the router section. So I can show you the next portion. Oops. Let's go back to our fourth program, that is nano4.py, and let's save this and run this. This program is the same, just I have added some more lines related to error handling. So it will configure 156, then it will configure 157, and then in the error handling section, so 157 is done, then it will go configure 158. You can wait, because the third device is unreachable. So it is throwing the same error. But I have added some more lines. And you can see. So now we are adding more and more items in the script. After that, we have one file handling. So far what we are doing, that we are taking the input. We are taking the input from the same place as a dictionary. But in case you have something is stored, this information you don't want to put here in the script, because suppose if you have 200 devices, you will not go and add all those 200 devices like this. So in that case, you may have some notepad, you may have some Excel sheet, right? From where you want to read those files. So in this case, what I have done that I have added the file handling. That means the IP addresses only. It will go and read from some file. So it should go and open one file, and from that file, it should go and read that IPs one by one. Since the username and password for all the devices are the same, so those things I have added, but IP address is a variable that will come from any of the file, right? And then it will go and push this configuration to those devices. So if I go and run this script, let me show you that. If I'm here to the terminal, and this, let's go to the files, see what error it will throw. It will tell that router.txt. is not there. You should provide a router.txt file I want to read, and then only I can go and do the configuration to these devices. And in that router.txt, you have to go and put the IP addresses. So let me show you that. We can go here and we can create the file, say 5.py. No problem with this. And then routers.txt, where I can go and provide the IPs 7, 8, for example 9 also, but I know that I don't have 9. And then if I can go and run this program, oh, I have added, which program I copied? Menu. Oh, I have added menu as well in this program. Yeah, I have added menu as well. I'll explain you this menu here in this last program as well. But these are our project files actually. The 5 is our project. So this is a long program, and I will give you one day time that you go through all this program. I'm going to upload these programs in the shared drive. You have a look on this program. Try to set your own lab that I have created, right? And in the next session, we will go and check this complexity in this program, this complex program, right? I'll not complete this because same day we have done the CCNA project. We have seen that actually, and then we are doing many things. It will work. So one by one, it is reading the files from router.txt, is configuring this devices, and I have made this menu. For example, you just wanted to configure ACL, or you just want to configure the interface, or SNMP, or AAA. You want to take the backup for the configuration. For example, I want to take the backup. Take the backup router configuration. So it got saved inside backups router backup txt. At the moment, I'm just showing you the result, and then I want to exit. You can see it has created backup file folder actually, and you can check this router backup. You have the configuration backup for R1. You can see here in this folder, I have configuration backup for R1 and R2 because these are the reachable devices. Took the backup. So we'll discuss about these programs in the next session. Meanwhile, you can go and have a look on.
Ratnesh,
Yeah, let me pause the
question.
record.
What is in the automation server? What is there? Is a Python runner or what? What is there?
Automation server is just a one Linux server, and in that we have Python. That's it. Any
If
Linux
wants to run
server.
this in my life in my regular network, I have to use Python in my computer.